My talk is going to present a massive scale lookalike audience extension system, which is running in production in Yahoo. Let's first start with an example of ad targeting. Suppose I went to this page. I was reading an article about a kitten playing with the little boy's toys. And I saw the two ads, which are shown in the right top and bottom in the red frames. Those ads seems they are not targeted to the context of the article. Otherwise, I would be able to see Petco or PetSmart ads. Instead, I'm seeing the analytics ad and LGLTV ad. So prior study has shown ad targeting is quite prevalent nowadays in online. They can target users' online profile, like users' online interests, users' demographics, and also the context of the page, which is not the two ads targeted to in this example. And in ad campaigns, there are two types of users that are very valuable to ad campaigns to measure their performance. One is clickers. That means, for example, if a user click on for example, the Best Buy ad, that is the ad clicker. The other one is converters. If the user eventually bought the LG HD TV from Best Buy, after clicking on the ad, he will be considered as a converter. That means a user eventually finish some transaction. In the conventional setting to do user targeting, the advertiser comes to the ad platform with some budget, and they want to target users as effectively as possible. That means targeting the users who are more likely to click on the ad or to convert to finish a transaction. And then they have to find how to find those set of users. In the conventional way is they are trying to make inferences about the user's interests in the past, like the converter's interests in the past, or making inferences about the future potential converters in the future. And then they come to the ad platform and pick the set of user interests from the provided list and saying, I want to target this set of user interests. I want to show my ad to them. However, for example, is like advertiser who is selling men's shirt. They want to target users men and also maybe like outdoor sports. Maybe those users are more likely to purchase the shirt. As we can see, the main challenge here is that it is really hard to optimize which set of interest the advertiser should target. The challenges are twofold. First fold is they have to do the user analysis and the mining work on their own. Second, of course, they can work together with the ad platforms, with the account managers, but that is still a mining work. Second one is ad platforms, they have their own set of understandings of users' interests and profiles. And then they have to make the alignment of ad platforms' understanding with advertisers' understanding to align those understandings together. So our starting point is how to free advertisers from these challenges and present them a more friendly and easier to use targeting product to make them target the effective users easier. So comes this lookalike audience modeling. The formal definition of the definition we consider in our study is the advertiser provides the ad platforms a set of users as seed user. That means these are the most valuable users we consider. And then those users are specified by browser cookie ID, mobile device ID, or email, and etc. Of course, those are hashed, and to make the user IDs are privacy friendly, to anonymized. And then another input to the system, to the model, is the whole pool of available user in the advertising platform. That is user set U. And each user in the pool, they are represented by a profile, which the profile is composed of binary features considering this study setting. It can be generalized. And the users have different features to compose the profile snapshot. And that's the users we consider. And then output of the modeling efforts is we want to generate a set of users A, such that each user in this set, they are similar to the seed users provided by the advertiser. So, for example, their similarity should be above some threshold tau and defined by our system. How to use the output? And then the ad platform, they will try to show the advertiser's ad to the only limited to the set of users we generated to the user set A. So that is how we generate a set of users for advertisers to target. However, there are two main challenges, and we want to talk in detail in this presentation. The two challenges, first one is scalability. So suppose an advertiser comes to the ad platform, they want to find similar users from the platform in under a few hours. However, in practice is that the seed list provided by the advertiser, they can be millions. Millions of users they can upload. These are my valuable users. And then considering the whole user pool in ad platform, that could be billions, in the scale of billions of users. Consider the browser cookies, device IDs, email IDs. So those are users, compose a large active user pool. And the third fault is there are thousands of campaigns that are running in parallel. They are asking to generate the audience for them at the same time. And then how do we satisfy all of them? Second challenge is the quality. Although we define our problem as to find similar users to the seed user provided by the advertiser, ultimately, the advertiser, they want to get more clickers, more converters from the audience. So they can consider more about the performance of the audience we generated. So how to consider that? We approach those two challenges in two-phase approach. In phase one, we tackle the scalability challenge, which is done by the hashing techniques. And we use the well-known, well-studied mean hash LSH locality-sensitive hashing technique to process the whole pool of users in one pass. And after the end result of this pass is that the users who are similar above the threshold tau defined by us, they will fall into the same clusters. And so the similarity here is defined by Jacquard similarity. And then at the query time, after this user pre-processing is finished, at the query time, we are given one user, a new user, and we just carry out the same hashing procedure on this user, and the user will fall into some clusters. And then all the users in those clusters are the similar users to this query guy. So that's how we achieve the similar users selection in sublinear time. And then next step is we have to consider the audience quality. The advertiser come to ad platforms. They usually come with a budget, and they want to spend the budget and get as many converters as possible. Consider in the phase one, the output could be tens of millions of users. And then how do we score them or rank them and select the most promising users from the larger candidate and return to the user? There are many approaches available to score the user. For example, we can do similarity. We can score them based on similarity to the seed user. We can build a classification model and use the model's prediction score. Or more conveniently, we can use the feature importance to the conversion to use the prediction power of the features to future conversions. As a simple implementation, we use a univariate analysis approach, information value, to measure how important the user profile features are. Intuitively, the IV of a feature measures how powerful can this feature distinguish seed user, which are the converters, versus non-seed user, which are the non-converters. And then we can score them. The property of this IV is that it it will just favors the feature who has larger coverage in the positive examples rather than in the negative examples. And we did some filtering, so we can just select the ones that are more significant in the positive examples. After we finish computing the feature IV for each of the feature, and then we can sum up, we have to generate the user score. One easy way is to do an addition of all the feature importance of the user. And that is one simplest implementation. We have done offline experiments and also online experiments before our deployment. In offline experiments, we try to simulate the situation of app install campaigns. App install campaign is that the advertisers, they are the developers of the apps, and they want to promote their app and get more new installers, as many as possible. So they come to us, and they will give us a list of the existing app installers or the existing users who made in-app purchase, which are more valuable to the app developer. So those are the seed users. In our simulation, we took the installers of 100 sampled apps from May 2015, used them as the seed user, and then all the active users in May as the whole pool of users we consider. And the user features, including their demographics and the apps they used, the categories of the apps they used, and also the type of ads they clicked or converted in the past. And then the test audience is like, your test audience is from the new installers from next month, June. That means testing if our recommended audience or generated audience, are they going to install the app in the next 2 weeks? That is how we test this prediction power. The measurement is on the installation rate. That measures the ratio of app installer versus the overall users we generated. This summarizes the results of the offline evaluation. The plot shows our model, LK, as our lookalike model, comparing to a logistic regression model, a segment-based model, which is from the previous work, last year's KDD's work, and also a naive Jakarta similarity model. The x-axis is the audience size. We vary different audience size and see if the ranking scheme works. Those are in the scales of millions. And y-axis is the installation rate. It's scaled by some constant to anonymize the real number. As we can see from the result, our proposed model, they performs at least like 50% better than other methods at different scale of audience size. And the logistic regression model, all of expectation, it didn't work very well at larger audience size. And then our hypothesis is that due to the sparsity of user features and at the larger audience size, the signal to noise ratio just damage this performance. In the original setting, in the global user similarity graph generation, all the features are considered as equally. Their weight are equal. But if we consider the user activities recency and intensity, for example, if I play Pokemon every day and 10 times 1 hour versus some colleague who just played Pokemon just once a week, so our profile should be totally different. Our interests should be different. And if we consider those recency intensity features, and we can achieve constantly 11% improvement on the installation rate. So in summary, our model works on billions of users efficiently. And the model has been deployed in production, and it achieves 40% improvement on the conversion rate, and also 50% reduction on the cost per conversion. And for the future work is one of the two main feature work we want to concentrate on is how to learn the user hashing function based on the real-time feedback, and which is not utilized right now. And the other one is the current system, it considers the static snapshot of user pool and then generates audience from that pool and use for next day. But how to handle the new users coming on the next day. For example, new browser cookie coming into the system, how to consider those guys. Yep, so that's all, concluding my presentation.